Hello everyone, this is our machine learning group assignment. Today we are going to show our project that we built to solve a real banking problem using machine learning. Okay, so what is our main problem? Problem is banks call their customers on the phone to sell them a product called a term deposit. Term deposit is basically when a customer puts their money in the bank for a fixed time period and earns interest on it. So the problem is the bank does not know who will say yes and who will say no before making the call. That's the main problem. So they call everyone, but in our data set, only 12 out of every 100 customers said yes. That means 80 calls out of 100 were completely wasted. That is a lot of time wasted and money waste. So our question is, we can use machine learning to predict who will say yes before the calling them. That's our question and main problem. We are using a real data set from a real bank. So it has over 45,000 customer records. This is the bank full CSV file. This has all the age, job, material, education, like all data. It has 45,000 rows. You can see like that. And each record has information like customer's age, job, account balance, whether they have a loan, and how long the last phone call was, like that. And we built 4 machine learning models to predict whether a customer will subscribe yes or no. Each group member worked on one model. There are main 4 models, and this one is pre-processing part. And let me now quickly introduce all 4 models before each member explain they are in detail. These are the 4 models. Before this, I explain what is this. This is the pre-processing part. Before all members doing this assignment, I created the actually create the pre-processing code. This using pandas, matplotlib, seaborns, scikit-learn. We use imbalance also. This dataset is loaded, and we got first what are the main yes and no target values. After we balance data using this smart function using smart, and finally save the clean data in here, clean data.csv. This is the clean data and balance data. We use the smart technology to balance. There are 45,000, no, actually 79,000 rows, because when we are balancing this, we have to add increase minority class. After we use these 4 random forest decision trees like all codes, SVM, and logistic regression. Simple introduction for all algorithms. We use 4 machine learning, supervised learning algorithms, random forest, SVM, decision tree, and logistic regression. Supervised learning means we train the model using data where we already know the answer. That means labeled data. The model learns from that and then predicts answers for new data. That's the machine learning, supervised learning works. Here are 4 main models example. First one is random forest. Imagine asking 200 different people the same question and going with the most common answer. That is what random forest does. It builds hundreds of small decision trees and takes a majority vote. Because so many trees are voting together, it is very accurate and rarely makes big mistake. That is the random forest. Second one is support vector machine, SVM. This is imagine like you have 2 groups of dots on a piece of paper, one group for yes customers and one group for no customers. SVM draws the best possible line between the 2 groups. Like this trick, we can predict the best one. Third one is decision tree. This one this one works like a game of 20 questions. The model asks simple yes or no questions about the customer, like is the call longer than 5 minutes, or does the customer have a long, like that, and follows the answers until it reaches a final prediction. It is the easiest model to understand because you can see every step it takes. Fourth one is logistic regression. Logistic regression is model calculates the probability that a customer will say yes. A number between 0 and 1, if the probability is above 0.5, it predicts yes. If it is below the 0.5, it predicts no. It is fast, simple, and very easy way to explain, which is why banks use it in the real life. Now let's hear from each member about their model, starting with member 1, random first. Thank you.
Random forest. Random forest was by the person. Yes, many decision trees. Sometimes each tree is trained using different random versions of the data. When we make the prediction, every tree is one and the final. This is powerful because tree can make, but when many trees work together, the overall prediction becomes much more. It is similar to asking advice from asking the group and with the majority opinion. Why did I choose random forest? Random forest when the states other directly defined field. Another that is this means blue tells us which factor most information is very useful because it helps them understand customer behavior Next, I will explain what I did with the dataset. Before training the model, our group cleaned the dataset together. The biggest issue was class imbalance. Only about 20% customers say yes, while the majority say no. This imbalance can confuse the model, so we use a technique called mode. Smode creates synthetic examples of the minority class until both classes become balanced. We also converted text-based features like job and marital status into numerical values because machine learning models cannot process text directly. After that, we scaled all features to ensure they are in the same range. Now, let's talk about how I trained the model. I experimented with different parameter settings, such as the increase and maximum of to finalize combination. And the select, and I also use 5 false cross validations. This means the model is tested 5 times using different versions of the dataset. Ensure that returns are reliable and then the result. My random forest model 92 0.9. The was code. Most important feature was call duration. This means longer calls usually indicate higher customer interest and a higher chance of subscription. Were also features. However, there is no this can use it for guiding who to call. Random for project. Thank you.
For this assignment, I am using the support vector machine algorithm. It's a supervised learning method used for classifications. So we use the bank marketing dataset from UCI repository. This dataset contains around 79,000 records with 16 input features such as age, job, marital status, education, like that. And the target variable is Y. It indicates whether the customer subscribed or not. This dataset is balanced dataset. It means it has equal number of yes and no responses. Firstly, I have separated the features and the target variables here. Because of the SVM is computationally expensive. For the speed purpose, I have splitted these entire recorder to I selected a sample of 15,000 records out of this 79,000. After that, I splitted the data into training and testing sets. For the training sets, 12,000 and the testing samples, 3,000 from these 15,000 records. I use the support vector machine model for model training. SVM works by finding the best boundary and it separates two classes. I tested two kernels, linear and RBF. The linear kernel works for the simple data. RBF kernel handle more complex patterns. To improve the performance, I use grid search CV. It's find the best parameters. The main parameters I tuned are the C, kernel, and the gamma. Grid search is tested multiple combination and selected the best model based on F1 score. The best model used the RBF kernel with C10 gamma scale, and the kernel RBF. The model achieved the accuracy of around 88%. The F1 score was around 0.89, which it indicates a good balance between precision and recall. For the positive class, the recall was 0.91. It shows the model correctly identifies most customers who will subscribe. This is the confusion matrix. This confusion matrix shows how many predictions are correct and incorrect. It helps us to understand the number of true positive, true negatives, false positive, and the false negative. And also the ROC curve shows the performance of the model at different thresholds. This AUC value is close to 1 here, 0.951. It indicates good performance. The overall idea is here, this SVM model perform well in predicting customer subscription. RBF kernel work better because the dataset contains complex patterns, so that it will help to the bank target the right customers for marketing campaigns.
Okay, thank you. I will present the decision tree model. This is my part, and this is the decision tree algorithm that I built. It all built using Python, and this is the imports algorithm decision tree classifier all imports. This is the clean data part and baseline decision tree before the tuning the model. This is the hyperparameter tuning with grid search CV, and this is the prediction part, and finally evaluation metrics using the our trained model, and this is the confusion metrics part, and finally we got the ROC curve, and these are the feature importance, and this is the depth and accuracy plot, and these are the finally Guinean entropy criterions comparisons in my decision tree part. This is the all codes, and I will explain what is the decision tree and their main features. A decision tree is one of the easiest machine learning model to understand. It works like a flow chart. It starts at the top with the full data set and asks a simple questions. For example, is the call duration greater than 300 seconds? If the answer is yes, it follows one branch. If no, it follows another. This process continues step by step, asking different questions until it reaches a final decision, such as yes or no. The model automatically learns the best questions from the training data. At each step, it chooses the question that best separates the data into clear groups. It uses measurements like Gini, impurity, or entropy to decide how good a split is. A better split means less mixing of classes. That means we want to less mixing classes to get the good prediction. One of the biggest advantages of decision trees is their simplicity. They are very easy to understand and explain. Even a person with no machine learning knowledge can follow the logic, because this is like a tree. This is especially important in fields like banking, where decisions must be clearly explained to customers or regulators. However, decision trees also have a main problem called overfitting. If the tree grows too deep, it tries to memorize all the training data, including noise. This results in every high accuracy on training data, but poor performance on new data. To avoid this, we control the tree size using parameters like maximum depth, minimum samples per split, and minimum samples per leaf. Using these, we can avoid this. In our implementation, we use grid search, this one. Grid search CV with cross-validation to find the best parameters. The best model use entropy as the criterion, a maximum depth of 10, minimum sample split of 5, and minimum sample sleep of 2. You can see it in here. And the model achieved an accuracy of 80%, and an AUC score, you can see in here, nearly 80, 90, and the AUC score of 0.9, this one. Showing strong performance. So we also analyze feature importance. Call duration was the most important feature, followed by previous campaigns, outcome, and account balance. We also observe that as tree depth increases, training accuracy keeps increasing, but test accuracy peaks and then slightly decreases. This clearly shows overfitting. So finally, in conclusion, although the decision tree was not the top performing model, it is the most interpretable, every decision tree clear and visible, making it very valuable in real world applications. Thank you.
Hi, I'm Sachin Transara. My model is logistic regression. What is logistic regression? Logistic regression was deployed by David Cox in 1958. He is the oldest model in our group. Even though the name says regression, it is actually used for classification, predicting yes or no. The way it looks work simple. The model looks like all the customer features, age, balance, sell, call durations, and so on. The multiplies each one by learned number called a coefficient. It adds all these together to get the score. Then it passes that score through a special function called sigmoid function, which converts it into probability between 0 and 1. And each coefficient tells us directly how much a feature affects the prediction and in which direction. This is something no other model in group gives so clearly. The direction for each feature's effect. And what is regularization? To stop the model from overfitting, I use something called regularization. It adds a small penalty for every large coefficient values. Keep the model simple and generalizable. The strength of the penalty of controlled by setting called C. I trusted many values from C, very small to very large, using grid search CV. I will explain later. My analysis showed that the model performs stably across wide range of C values. This is not very sensitive to this setting, which is a good sign. Then how did I train this model? And I use imports algorithm logistic regression first, and pandas, numpy, skitlearns, everything, and then I load the clean data. This is our data folder. Bag full CSV is a raw data set, and we have cleaned data set for balance. Then I load the data in here and get the training sets and testing set. Also the use baseline logistic regression and also get the baseline accuracy. Have a parameter turning with grid search CV to get fitting 5 folds of each 12 candidates, totaling 60 fits. Also receive the best parameter and the best CVF1 score. And they also apply predictions and evaluation matrix to get classification reports, accuracy, ROC, AUC score, average precision score, and CVF1 5 folds. And the confusion matrix, like this is a confusion matrix chart, predict labels and true label, get those labels, and ROC value for get the curve of the ROC, and logistic regression AUC value 0.920, and the precision recall curve to get the average precision 0.98, and the feature coefficient get the features coefficients, like these are the top 5 individual features. And regularization strength C versus accuracy, get the yellow line is a test accuracy and the purple line is a train accuracy. Solver comparison to get 3 layers of comparison. These are my model summary, training model summary, and I use grid search CV with 5 folds cross validation to find the best C value and solve, which the model used to do the math behind the scene. The best result came from the C to equal 10 LB FGA solver. And what were my results? My logistic regression model get 87 accuracy. F1 score was 0.87 ROC. AUC was 0.94. That's the 4th in our group, but only 5% behind Random Forest. And here to is the key point. Logistic regression trained just a few seconds. It is a fastest model and it is the most important, transparent, and real bankers actually use this exact model. They are credit storing systems every day. If I had a recommendation for the one model for the real banking right now, I would say with the logistic regression, it is simple, fast, explainable, and good enough. You can use always, upgrade to Random Forest later if you need an accuracy. Thank you, and back to the group for the conclusion. Thank you for all our 4 members. Let me quickly summarize what we did and what we found. We started with a real banking problem, predicting which customers will subscribe to a term deposit. We used real data set with 45,000 customer records from the Portuguese bank. For machine learning models, we are here to how they perform. Random Forest 92% accuracy, best overall grade for production use, and SVM 90% accuracy, second best, strong but slow train. Decision tree is 88 accuracy, third. most easy to understand and explain. Logistic regression 87% accuracy, fourth and fastest, simplest, and most suitable for the real banking systems. If the bank uses the best model, random forest, to target only the top predicted customers, calling everyone, it could save a huge amount of campaign cost while actually improving result. Thank you so much for watching our presentation. We hope it was clear and easy to follow. Thank you.